Welcome back, everyone. So I hope you're doing good. So this will be, I think, sixth video of our series from counting numbers to quantum computer, and we are very close to calculus. That will be, I think, in next video, and then we are very close to doing some work, creating some model in AI. So if you are just there, I'm just I just want to say you're just there to see the magic, and uh, and so we'll start. Today I want to discuss some functions, and which has been a very anecdotal for me, as I've seen a lot of people talking about, hey, what is sine, cos, tan, never used in my life and everything, right? I've seen a lot of people complaining that. And problem is that a lot of people didn't understood it well. What is sine, cos, tan, whatever is that, right? For me, for a long time, I didn't understood it. I just memorized thing. I just did it. Just a lot of time in Indian education system or maybe somewhere around the world, lot of people solve problem using pattern recognition without understanding, just using pattern recognition, right? Just like how chat gpt work, it most of the time doesn't understand the problem, just uses pattern recognition, see some example and just mimic those example, change few things here and there, and good to go, something like this. And that was the same case when I was learning math and science. Was this thing I did the same way. But when I actually started applying math in my daily work, like in quantum computing or in machine learning, then I get to understand these things better. So I'm going to talk about sine function, cos function, tan function, logarithmic, exponential. What are those things? And these are really much prerequisites to lead us to into calculus and everything, right? So we are here to learn that. And let's start with some basic functions, which we'll see. Function, as we have already talked about, it's nothing, it's just you pass some input and get some output. That is basically function, right? One of the simple function which we have already seen, y is equal to 2x plus, you put in some input, you put out, get some output. Let's say if I pass 1, you'll get 3, you'll pass 2, you'll get 5, 3 and 7. And if I have to plot that function, it will look something like this, right? So this, I think, we have already seen in our previous video called function and coordinate. If you haven't watched it, you can watch that. The next function we'll say little complex. We call it quadratic function, and then it's a x square function. So it doubles everything, right? So you can see pass 1 by 1. If you pass 2, it becomes 4, it will 3 and 9. So you can see this curve over here. So this represents that function, right? Now the technotic function sin x, right? Which we have seen a lot of time. What that means. So usually our function has some variable x square or x or something like this, right? And this is a short form of this function. This function doesn't look something like this, right? This function is basically something like this, where you pass on some value of x and you solve this thing, then you get some output, right? And that same thing could be written in this form. Usually this doesn't has to be have 6 terms over here. It goes on and on. After this 11, it would be 13 permutation combination. If you don't know this exclamation sign, this basically means 3 multiplied by 2 into 1. 5 exclamation basically means 5 multiplied by 4 into 3 into 1, right? So this is short form of writing that kind of series. So this sin x function is basically an accumulation of lot smaller function like this, and it goes on and on like to the infinity, right? So somehow we made a shortcut way to define it, sin x, and it is a periodic function. Basically what I say, its value kinds of repeat, that you will understand once you see its graph. So it goes something like this. If you pass on x value, you pass inside this sine is basically this function. You calculate these once whatever input you have as a x, you pass it over here, solve it, and you'll get some result, right? So if you see this, if you pass 0, you'll get 0. If you pass pi by 2 is we are using pi is basically a number 3.14, something like this. If you remember, pi is just number. If you divide this value 3.1, you will get 1 point something like this. If you pass 1.1 or something, you'll get either 1 or 0. And if you pass pi, basically pi is basically 3.14. If you pass input as the value 3.14, you'll get the y value 0. So if you see, if I do more number, you will see the output always is between 0 and 1, right? That I can see in our graph. When we plot this graph, pi is over here basically 3.14, nothing else, nothing more, anything like that, right? That is pi. Sorry. Yeah. So pi is basically 3.14. If you write 2 pi is basically multiply by 6, that becomes 6 pi by 4. So that you can see over here. Skipped it somehow, but yeah, this will be over here. So you can see this is a function, and if you see the output value, this is basically 1 over here, this is 0. So whatever input you pass from over here, pi 3.14 or something, you will get an output 0 over here. If you just pi by 2, which is over here somewhere, you'll get this value. So none of the answer exceeds the value 1. So this is 1, or this is 1 as well, 0. So all the values, whatever input values you pass on to the sine function, all the output are confined between 0 and 1, right? So either you'll get negative, is this a negative 1? No, yeah, negative 1 as well. So either negative 1 or positive 1, something like this. And they go periodic. And one of the reason you can question yourself, like basically why we use pi over here, because this is a periodic function. This cycle after 2 pi again gets repeated again, right? It's like a circle. Yeah, once the circle is complete, you tends to, so if I have to write 4 pi, right? So value of 4 pi will be equal to 2 pi. There is no difference between, because the cycle is already completing. If you're not understanding this part about pi, it's okay. Just understand that you're first just passing the value 3.14 or something like this over here. If you solve this, you'll get 1 point something values over here and you'll get 1, right? So pi helps you to, you don't have to know all the values over here. I just need to find values from here and probably same values will be repeated or any input, either this side or this side, right? And if you see this, the exponent, we call it Taylor series expansion of sine function, right? So the real value is how a function looks like. And if you see, it is x minus x cube upon this 3 number is common over here, and these are all odd numbers. If you see 3, 5, 9, 11, right? These are all odd numbers that you can notice. So now what we do is we go to another function, cos function, which you might have heard about, which is opposite of sine function, right? If you see the Taylor series for it, right, and the short form is we write cos, but the series looks like, you see all the numbers are even over x square, x4, 6, 8, 10, something like this, and it goes till infinity. And if we pass on value 0, you'll get 1, if you pi by 2. So it's all opposite. If you see, the values are all opposite. It look very similar to sine function, but the sine at 0, it's basically the line started from here, and then we grew up like this and this thing. But in cos, it's a little different. It starts from 1, and then goes to -1 over here, and then again goes back to +1, and then -1. Right? So basically, the difference between sine and cos, where they start. Sine starts from somewhere 0, and it starts from 1, right? And this is again periodic function. And whatever input you do over here, you will get only values between 1 and -1, right? And if you see, there is some correlation between sine and function. The cos function is made from these even terms, right? And the sine function is made from odd terms, right? And we have another special function just like sine, because we have exponential function, which we're going to see next. So exponential function we can also break down into a Taylor series. What this means, basically this series looks something like this and goes till infinity. You can write maybe like this, and if you see over here, if you pass 0, I'll get 1. If you pass 1, I'll get e. E is basically a number between 2.17, just like pi has this value 3.17. E is also a number, I think 2.147, something like this, right? And you can replace that value over here and we get these values. And if you see one pattern over there, this exponential is actually made from sin x and cos x. So if you see over here in cos x, we have this exactly same term, x square by 2, x square by 4, right, x square by 6. And in sin x, we have this x value, and then we have x cube divided by 3 factorial, and then 5 this odd terms, right? So you can see if we combine sin x and cos x, we will find this exponential function. So Euler did a lot of work in this kind of field, uh, and this will be very much important when we actually start learning quantum computers and everything, how those things, how the rotations and everything. I will probably put a video about matrices and vectors, how matrices and vectors work, right? In what way? Though that will be also an interesting thing to see. So these are somehow related. If you don't understand what I just said, it's not necessary for this part of the course, but I just want to let you know there is something relation between ex and sin x and cos x, right? Probably ex is equal to cos x minus sin x, right? I sin x. Then there is a complex number and everything, right? So you already have learned about number system in our initial videos. So we will get into complex number as well. So right now I haven't taught you complex number. That's why I don't want to get into Euler's formula right now. But we'll soon be coming over there. So this ex function, you part some values, and you can see its diagram. It goes up and up like this thing. The more input you go, the higher the values become, right? Initially you will get some low value. Exponential functions, they start pretty slow, but as soon as they go little forward as input, they becomes very high number, exponentially high. Right, that function looks something like this. Okay. Basically, it adds the value times 2.17. Whatever if I go over here, the slope for ex is actually ex. We haven't talked about this much, but we'll probably see when we learn calculus how we can find the slope of ex. So this is our function ex. Same way the inverse function, just like sine's inverse was cos x, right? They pretty much look similar. Their inverse was cos x. Same way this exponential function we have called something called log x, right? Just like sine have this shortcut name, this has a shortcut name like this thing. And there is no value for 0 in log x. That's why we are adding 1 over here. So whatever input you'll get, it will become 1 first. Like it will add 1 automatically. I'll get these values. So if you put 1 over here, you'll get 0. You'll put e, basically 2.17, you'll get 1. If you square 2.17, basically 4 point something like this, you'll become 2. Right? So you can see over here, this is a function over here. And it is quite opposite. If you see even function, right? If you just invert this function, look like ax. Right? This is our logarithmic function. And do we have one more function? Yeah. I think yeah, that was it. So I hope now you have understood what this sine is, like where this come from alien world or something. It's nothing new. It's just a function, and because this function looks very long and periodic, because the numbers are reoccurring over here, we cannot always write this big chunk of function every time whenever you use. So we gave this short name sine x, right? Same way, cos x has a big function, x square, odd numbers, right? Even numbers, sorry. There's factorials and there's this big, like infinity till infinity. We cannot write those things, so we just use a short name for that function, cos x. But just like x square is a function, 2x plus n is a function, right? X cube a function. Similarly, these are a function. It takes some input, gives an output. And for a long time, I didn't understood this in my high school, and it was terrible. It was terrible. I was following bunch of rules and doing some integration problems and differentiation problems without understanding what actually I'm doing, where this function comes from, right? And we'll see a lot of application where this sine and cos function are. So there, if you remember, their outputs are between 0 and 1. They're like swinging between, either they are 1 or 0, right? Their outputs are. And what is a common example? When you see a pendulum, right? That kind of has a similar motion how sine and cos have. They go from one point to another, and there all the values are limited between 0 and 1. So whenever we have to describe the motion of pendulums and this kind of thing, we will learn probably this in physics. If you're with me, I might start a physics channel where I'll teach about this thing, motion of a pendulum. So their values are kind of between 0 and 1, right? So to represent that kind of a motion, you need these kind of function where their values are only swinging between 0 and 1, right? Lot more time the function which we see, if we give output, we get some bigger number, right? We never have this limiting output. Outputs are like beyond, like if you have a big number of input, probably get a big number output if it is a square function or something like this. But for the first time, we are seeing a function whose outputs are limited between some value, right? And its form, the terms which constitute this function are very big, like these factorials and exponential. So we write it in a form a smaller name called sin x, cos x, tan x, right? And log x, logarithmic, exponential, and these are kind of. I hope you understood. Probably next video will be, I'm very excited for it. That will be on calculus. And I'm going to teach you calculus that you'll feel like you have invented the calculus. And I really wish that somebody would have made this kind of video way back when I was learning it. And that has been inspired from one of my mentors called Derek Owens, who I'll talk about them when I make that video. So really excited that we'll see that. I'm really excited that you guys are there for that video, and we could have some fun over there. So see you in that one.